Good morning, students. Students, this lesson is of class 9th for the subject of mathematics, chapter 16, area and perimeter of two-dimensional shapes. Starting on page number 16.1 of your textbook, and is being submitted to you on 7th December 2020. Now students, what are two-dimensional shapes? First of all, 2D stands for two-dimensional. Clear? A two-dimensional shape is any shape that has two dimensions. If we had only one dimension to work with, we could only move backward or forward in a line. A line is one dimensional. Clear? Now students, in mathematics, a flat surface is called a plane. Two-dimensional shapes are the flat plane figures that can be represented on a piece of paper or flat surface. Clear? These shapes have length and breadth, but no considerable width or thickness. Shapes like circles do not have any length and breadth, but it can be defined by a radius, which is actually the distance between its center and boundary. So circle is also a two-dimensional shape. Clear? So examples of two-dimensional shapes are rectangle, circle, square, triangle, quadrilateral and pentagon. Now these are some of the examples. We can have more also, right? Now let us learn various types of two-dimensional shapes. Now students, first of all, examples of two-dimensional shapes are plates, cards, sheets, clocks, windows, etc., which are found in our day-to-day life. Clear? Now students, let us discuss about perimeter and area of two-dimensional shapes. So first of all, let us see what is a perimeter. The perimeter of a plane figure is the length of its boundary, that is, the sum of its sides. The unit of perimeter is the same as the unit of the length. So that means we add up all the length and we will get perimeter. Clear? Now the next is area. The area of a plane figure is the measure of the surface enclosed by its boundary. That is the surface enclosed by its sides. Clear? Now students, in this chapter, we shall learn the formulae for area and perimeter of triangles, quadrilaterals and circles. Now let us discuss about perimeter and area of triangles. The first method is area of triangle is equal to half into base into corresponding height. Students, any side of a triangle may be taken as base and the length of the perpendicular from its opposite vertex. Now suppose AB is the base, then you can take CE will be the vertex. Clear? So in this triangle, area of triangle ABC is equal to half into BC into AD square units. I hope it is clear to everyone. Students, this formula we have already done in the previous classes. So you will find this formula very easy to apply. Clear? Now the next formula is Heron's formula. Students, we apply this formula when we know all the three sides of a triangle but perpendicular is not given. Or you can say the height is not given. Clear? So here let A, B, C are the three length of the sides of triangle ABC. Now we have taken small a, small b and small c as the length of its sides. So students, we know that the perimeter of any triangle is sum of all its three sides. Clear? Now here we will find first the semi-perimeter. Now what is a semi-perimeter? Semi-perimeter will be A plus B plus C divided by 2. Clear? So the formula is area of triangle is equal to square root S. S is what now? Semi-perimeter. Then S minus A, S minus B and S minus C. Clear? So this is called Heron's formula. Now the next method is for any right angled triangle ABC. Now let's see what we have. If we have a right angled triangle ABC, then what is the area of this triangle? It will be half into base into this height AB. Clear? Now you can take AB as base and BC as height, or you can take BC as base or AB as height. Clear? So in this triangle you can see angle B is 90 degree. So if we have to find the value of AC here, how will we find? We will apply Pythagoras theorem. That is AC square is equal to AB square plus BC square. Clear? And if we have just to find the area, then in that case area of triangle is equal to half into product of the sides containing the right angle, that is AB and BC. I hope it is clear to everyone now. So these are the three methods to find the area of given triangle. Clear? Now students, let us discuss area of an equilateral triangle. You know what is an equilateral triangle? Yes, when all the three sides are of equal length. That is AB is equal to BC is equal to AC. Clear? Now students, here let us assume the equal sides as small a. Now let us see how to derive the formula of an equilateral triangle. Clear? So let ABC be an equilateral triangle with side A and AD be the perpendicular from A to BC. Then D is the midpoint of BC. Clear? So let us assume BD as A upon 2. Now why a upon 2? Because BC we have assumed as a. So half of a is a by 2. Now let us apply Pythagoras theorem in triangle ABD. So here it will be AB square is equal to BD square plus AD square, right? Or you can say AD square is AB square minus BD square. Children, you all know how to apply Pythagoras theorem. So let us find the value of AD here. So what will be AD here? AD will be A square minus A upon 2 whole square. So that will come out to be 3 upon 4 A square. Now children, so area of triangle is, now before we find the area, now what is the value of AD? That is root 3 upon 2A. So this is basically the height of an equilateral triangle. Clear? Now we know that area of any triangle is equal to half into base into height. Now see here, in the same triangle, BC is the base and AD is height. So we have assumed BC as A and AD we have just now calculated as root 3 upon 2A. So what will be the area of an equilateral triangle now? That is root 3 upon 4A square. I hope it is clear. So students, we can directly use this formula whenever an equilateral triangle is given to us.